Welcome to our next talk. Well, as you might have known, wireless LAN is no rocket science anymore, but wireless power has some problems. And here's a speech about some solutions, because using sun is everywhere. Just have a look at what Michael Script has talked about. He has some devices with him. Give him applause.
Thank you. Thanks for coming. Quite a few people here. I didn't think sunlight and geek would go together at all, but well, that's okay. Don't be afraid, there will be no live demo today. That's all right. Okay. This is the outline of my talk. We'll first discuss the solar panel, some basics. Then I'll show you how I connected everything, some introduction to voltage regulators and buffering the energy. And at the end, I'll show you some practical applications for powering your laptop or your mobile phones or everything else. So that's about me. I'm 23 years old. I'm a computer science student in Kaiserslautern, and I've always been fascinated by electronics, and I've always been making stuff. And this project began this summer, where I ordered a solar panel and tried experimenting with it. Yes, licensing. This talk is licensed under the following conditions. You probably know all these. You're free to share under the following conditions. There's some little disclaimer, because this project involves high currents and high voltages. At least someone could consider these voltages dangerous, so please be careful. And there's absolutely no warranty, so you could easily fry your laptop or mobile phone or whatever using what I tell you here, so be aware. Okay. Why am I doing this? Well, first of all, solar power is a cool thing. It's just fun. And if there are no power sockets around, you could just use the sun to power your devices. It's not yet to save money, because these panels are rather expensive. It's about 50 euros for 10 watts, 60 US dollars. I'll show you later the module I used. It's a 40 watt module, and I spent around 200 euros. So not that cheap. And you will need some more money to buy a voltage regulator or build the power meter. I'll show you later. So let's first talk about the solar panel and its characteristics. Every module is characterized by its short circuit current. That's the current that flows when you connect both terminals. The open circuit voltage, that's the voltage you can measure when nothing is connected to the panel, and its maximum power point. And this is the point here where you can achieve the maximum power out of the module. You can see here the shortcut current, and here the open circuit voltage, and when you apply more load, the voltage will go down. And there is one point for each panel right here where you can get the maximum out of it. And this is under testing conditions, and under more typical conditions, the shortcut current will drop significantly. So if you don't have that much radiation, or if the panel gets hot, you won't get the power out of it you usually do. So what you need to pay attention for is that you always have some buffer, so that your devices will work under different conditions. Well, then you have to decide what do I want to power. Is it a laptop, PDA, phone, or do I just want to charge some batteries, or do I want to power an electrical fridge, for example, or do I want to power an inverter so that you can connect other 230 volt devices to it. And well, might it possibly work? That's a good question. You should have a look at the ratings of the original power supplies of those devices, and you can then just try to plug this device to an adjustable power supply. If you don't have one, try to find a lab someone where you can use one, and well, try to power it. And if that doesn't work, it probably won't either using a solar panel. So that's what you should do first. And of course, voltages of the panel vary, so you maybe need a voltage regulator to create the proper voltage for your device you're powering. That's what I already said. First, try it using a simple power supply, and then you could try the solar panel. Yes, here's some example. That's the module I've used. It's very nice because you can fold it. That's the folded state. It's about the size of a sheet of paper. And if you unfold it, it looks like that. And that's pretty nice. And yes, our cat likes it too. And here you can see the ratings. Here is the short circuit current, open circuit voltage, and the voltage and current at maximum power. Okay, what else do we need? We need some connectors to connect all our devices together. Well, those devices should be common for all devices, so you could just plug it to your laptop or your PDA or everything else. They should be safe. That means you shouldn't accidentally short them or reverse them, as this would probably break something. Yes, support for higher currents, about 10 amperes would be nice. This is the solution I found. This is this rear connect series. You can buy these from Reichelt under these numbers. These are very simple, but you can't reverse them and you can't easily short them. Then for every device, you'll need an adapter. That's what I've used for my older ThinkPad. It's a simple DC plug. You can find the part number here too. And it just plugs to the other. This is a newer ThinkPad adapter I'm using here. These are hard to find. You could just cut it from a dead power supply or from a cheap replacement supply, because they aren't easily available. Nokia phones use two sizes. That's for the old one, and that's for the new devices. You can just use an adapter like this to power both. That's another nice thing. If you have 12-volt car equipment like chargers or GPS navigation devices or an inverter, I'll show you later, you can just use an adapter like this to plug everything that usually plugs in your car to the solar panel. Okay. I've already been talking about the voltage regulator. The output voltage of the solar panel will depend a lot on the load that is applied to it, and we also need to power a lot of different gadgets. So one might need 5 volts, one might need 12 volts or 20 volts. So it would be nice to have an adjustable regulator that can power all those. Here's what I came up with. This is a device which is based on this linear technology chip. And the nice thing is it's a step-down, step-up converter. So usually if you have a step-down converter, you must apply a voltage that's higher than the output voltage. And if you have a step-up converter, you can apply a voltage that's lower than the output voltage to get the resulting voltage. And this thing has both. So you could just apply an input voltage of 7 to 25 volts, and you can adjust the output voltage from 4 to 25 volts. And what's really nice about this device is that it is very efficient with an efficiency of up to 97%. So you won't lose much, and you don't need cooling and anything else. Yeah. I've used this device to power my older ThinkPads and ThinkPad X40, and you can also use it as a power supply to use in your car. For example, you can just plug it into your cigarette lighter and adjust the output voltage to about 15, 16 volts, and you can power your laptop in your car. That's a nice side effect. Okay, here's another problem I came up with, because many devices have small peaks in their power consumption. And these peaks will cause the voltage of the panel to drop. And some devices might have problems. For example, if you use a laptop, it might switch to battery power and drain the battery during these very short phases. Here's an example. This is an oscillogram of the power consumption I measured. It is measured across a 1 ohm shunt. And so 1 volt difference here means 1 ampere difference in the current. So we have a difference of 0.5 amperes here, so that means you have a difference in power of 10 watts. And this is just a simple window manager while switching desktops. So if you have a modern CPU, it will normally, it doesn't consume much power, but if you switch desktops, everything will be re-rendered, and it will consume a lot of power during that period. So I had the problem that I used this laptop with my solar cells, and every time I switched the desktop, it would detect AC not available, beep, and AC available again. So we need a solution to this problem. Well, some of you might know these devices. Some of you might have them in your car. I don't know. Those are really big capacitors, which are usually used in car hi-fi, because if you have a big bass, then your headlights might go dim when the bass kicks in. So these are to buffer the energy. Yes, and yes, another high current warning. Don't ever short them, because when charged they will produce extremely high currents. So you should use a fuse. You can see I've used one here to prevent fire or other damage. Yes, so what I've done is to connect this capacitor in parallel to the laptop, and if it is charged, it can supply the power that's needed for those tasks. Okay. When everything went fine so far, I wanted to know how much power does my panel supply at the moment, and how much energy am I currently saving. So I decided to build a little device. You can see the device here. It's rather small, but maybe the camera can capture it. It currently says, oh, it says nothing. It says about 19 volts, 0.5 amperes, so my laptop is currently consuming about 11 or 12 watts. Yes, these are the specs of this device. It's rather simple. It has a voltage range from 10 to 25 volts and a current range from 0 to 2 amperes. It's well suited for small solar panels. Here are the schematics, and as you can see nothing. It's just a microcontroller I've used here at Mega 8. This is the measurement bridge to measure the voltage across this voltage divider and the current through this resistor here, and an amplifier to amplify the current. Yes. What's it doing? It is measuring voltage and current using an analog digital converter. It then calculates the power and it calculates the energy. And it writes all these things to an electrical erasable, programmable read-only memory, so you can always see what energy you have saved over time. Yes, that's how it looks like, for everyone who didn't see it. Yeah. Okay. Now some practical applications. Let's first talk about the laptop. It is very well suited for solar power because it has a built-in battery. So if you have cloudy sky or someone walks past your panel and shades it, you won't need no other external battery to buffer those. Because every time the voltage is too low, it will switch to its internal battery and everything will be fine. Power consumption is around 10 to 30 watts, depending on the model. I'm not talking about some 10 pounds hardcore gaming laptops. They'll probably need more, but these are some typical values. Yes, that's another problem. Because if your laptop is charging the battery, it will consume a lot more power, about maybe 60 watts instead of 10 or 15 watts. So what you need to do is you need to prevent the battery from charging. There are many ways to do it. You could just use a full battery. It's full so it won't charge. You could use a very old battery because old batteries usually don't drain so much current than new batteries, so your panel will probably be able to handle it. Well, you can remove the battery so it won't get charged, but here we have the problem, what happens if clouds come up or someone walks across the panel. So that's no good option. Some laptops I tried worked also using voltages that were so low that no AC was detected, but they won't charge the battery, but they were still able to get power out of the solar cells. But that depends. For ThinkPads, we have a very elegant solution. You could use this power management interface. For example, I think someone of you has already done this. You could set the start threshold to about 10%. So your battery won't get charged until it's below 10%. I think there's also a Windows solution to set these values. Yes, here's a real example. That's when I got the panel, I tried it. That's not my power meter, there are just two multimeters. And yeah, it worked fine. Okay, some other applications. I tried to charge my Nokia phone, and I had the problem that it did not charge at all. So I had a look at the problem, and those Nokia original chargers have their current limited to about 800 milliamperes, and the phone will check the source, and if the current is too high, it won't start charging. That's probably because there is no internal limiter, and those higher currents would damage the battery. So what we need to do is we need to limit the current that flows through the battery and through the phone, and the most simple device is just to use a resistor to limit the current. Here are some typical values I tried out. Older Nokia phones need a slightly higher voltage to charge than newer Nokia phones, and using these values, charging worked fine. Okay, another nice thing, especially on a hot summer day, you could use your electrical fridge to cool your drinks. And those are quite simple devices. They only consist of a thermoelectric module and a fan. And they mostly rated at about 40 watts. And if your panel is not too big, you could just plug it directly into the fridge without any voltage regulators at all, and it will work. Okay. Another thing I've already said, you can use an inverter. Those are made for cars, so they usually need between 10 and 15 volts. So depending on your panel, you should consider using a voltage regulator or not. If you have a small panel, you probably don't need a voltage regulator because you won't get over these 15 volts. If you have a bigger panel, then you'll probably need a voltage regulator, so you won't damage your inverter. Yes, you can plug almost anything small into it, for example, small battery chargers or power supplies for mobile cameras or something like that. Okay. You can use this setup to power almost any low voltage device. You should just have a look at the original power supply. Here it says, for example, 5 volts. So you can just adjust the voltage regulator to an output of 5 volts. Usually you need no current limit, but remember the Nokia example, sometimes you need one. And if you have put everything together, you could just try it out, whether it works. Okay. Those are some references here. This is the this universal voltage regulator, and here's another documentation of this power and energy meter. So you probably have some questions. Yes, please.
Earlier you said you needed to stop the battery from charging. Why would you want to do that?
Okay, let's jump there again. Somewhere here. Okay, because normally, for example, this laptop uses about 15 watts. So it will work fine using a solar panel of, let's say, 30 watts. But as soon as the battery starts charging, it will consume much more power. For example, if this laptop charges, it consumes about 50 watts of power. So your panel won't be able to provide that power. So charging would probably stop, and as soon as the voltage is high enough again, it would start again, start again. So it would probably be a cycle. If you have a panel though that's big enough to handle charging, you can also charge your battery. Okay? Okay. Any more questions? Yes, please? Okay. You can just, I'll repeat the question.
How does the power scale in size of the panel?
In size of the panel. Okay. He asked how does power output scale for the panel size. And I don't know exactly, but usually if you double the size, not the size, the area of your panel, you'll get the double power output. So it's a matter of square. Okay, yep.
How much light do you need to power your laptop? When you said there's someone walking by the sun, I mean, does it work in a room like this, or how does it work?
That's a good question. We could jump back to this again. Typically, the manufacturers of your modules supply these values under testing conditions, under direct sunlight at 25 degrees Celsius. But when the intensity of the light gets lower, your power won't get lower. And it's, well, this setup here is just working under direct sunlight. So if there is some shade or some clouds, it won't work because power decreases dramatically. So direct sunlight is necessary. Okay. Yep. For the presentation, it's called impressive. You should. Impressive, yes.
How much is the step up, step down converter?
How much?
Euros?
You mean, where is it? I can find it. It's gone. Ah, there it is. It's very not very expensive, but it's rather expensive because of its high efficiency. So this model is about 50 euros. It comes partly assembled. You only need to solder these connectors to it, so it's no problem to rebuild it. This one. This is from ELV, where you can buy it. It's called USV 525.
Hello. I want to know how much does your panel weight?
The weight, okay. I don't know exactly, but it's maybe 2 kilos, 2 kilograms. It's not that much. And it's very compact because you can fold it, everything together. And there's no metal. Or
Transport is no problem?
Transport is great. It comes with an, you can just carry it like a bag. So that's okay.
Can you use them in Syria? So if you buy another one, is it just double everything or?
I didn't get the beginning.
So if you have 2 of these bags, will you have just will you just double everything?
Yes, if you have 2, you could just put them parallel, put the terminals together, and you'll get the double power. That's right.
You have thought about making a bending buffer for the design?
I've thought about it, but I didn't try it because I didn't want to carry heavy lead-acid batteries around. So I really wanted this simple solution that it's really portable. But it would be no problem. You could choose an. There exist ready-made chargers for solar batteries, and you could just use one like these.
And these panels, they degrade over time or degrade after usage?
Usually they have a guarantee of about 10 or 20 years. So between that in that period, they will have, I think, 70% of their usual power. So that's okay.
It doesn't matter how much you use it,
No.
as opposed to.
I don't
not
know
using it at all.
exactly, but I don't think so. Anyone else? Okay. If you have questions later on, you can contact me via IRC, or you'll find some other contact information on my personal homepage. Okay, no more questions? Thank you.